So this video will be on 13.2b. I'm doing B because if you can do B, hopefully you can do A and C by yourself, and because the basic ideas here will work for a lot of the other ones. So what we're doing is we're taking this picture of a function they just drew, and then we're going to change it. This is f of x, so call this f of x, right? Here's this whatever it is. And then we're going to do this to it. We're going to take 2x minus 1 inside the parentheses and 1/2. So which is kind of confusing. So here's what they mean. And the order really matters, and we'll go over that in a second. But to get this function, the first thing you got to do is get the x by itself. Okay, you just have to get the x by itself. 2x minus 1 doesn't work. We got to get 2 times x minus whatever that is. So step 1 is getting the x by itself. So let's see, that would be 1/2 f of 2 times x minus 1/2, because 2 times negative 1/2 is 1. Okay, so that's the first step there. And then always check. 2 times x is 2x. Yep, that's right. 2 times negative 1/2 is negative 1. That's right. Okay, now we're good. Okay, then once you have the x by itself, then the first thing you always do is dilate or compress in the x direction. So here's what's inside the parentheses is always the x. What's outside the parentheses is the y, right? Because this is the function of x. And that's why you always did that stuff, whatever in the parentheses, what we replace x with. So we're replacing our old x, the old function, with this. So what does that mean? Well, first it means that the 2 here means that we're going to compress it by 2 in the x direction. I draw it like this, compression in the x direction, because this is all x direction here. We're going to compress it by 2. That 2 makes it 2 times smaller. The x direction is always opposite of what you'd think. The y direction is fine. Vertically, it's fine. Horizontally, it's always the opposite. If you multiply it by 2, it makes it 2 times skinnier. So we're going to compress it by 2. That's what that 2 does. So the first step here is dilation or compression. Then we shift. Then we say, okay, but it's minus 1/2. Again, it's always the opposite. If you take away 1/2 from the x, you're actually making it go to the right by 1/2. So we're going to move it this way by 1/2. Okay, to the right because it's minus. Again, always opposite in the x direction. Now we got everything in the parentheses done. Now we go outside the parentheses, and where this is y, right, our new y, we're multiplying it by 1/2. The y direction is like you'd think. Multiplying it by 1/2 is compressing it. It's making it twice as big, twice as small, because it's 1/2 as big, right? Twice as small. And here's where, I don't know whatever makes more sense to you. We're compressing it by 2 in the y direction, or 1/2 as big in the y direction. It's, whichever way works for you. 2 times smaller, half as big. I don't know. I'm going to put a 2 there. Okay, so those are our steps. So we take our old function and we're going to do all these things to it. We're going to compress it by 2, shift it by 1/2, and then compress it by 2 again, but in the y direction. So let's do that. So there's our function. And it's really hard to actually do it to the graph. It's possible, like think about compressing the graph. What's a lot easier to do is look at the points that we know for sure, and we're going to do it to the points. So I'm going to do it to these points. I'm not going to worry about the endpoints. We could do the endpoints too, but I'm not going to worry about the endpoints. I'm going to worry about these points, and we're going to shift those points. Okay, so I'm going to write down all those major points first, the points that we know where it hits the axis and stuff. So those points are, the first one looks like it's -2 and 0, and then -1 and 1. There's 5 of them. 2 and 3, and then 3 and 0. Okay, those are our points that we're going to do our things to. Okay, so first we're going to compress in the x direction by 2. In other words, we are 1/2 in the x direction. So this is basically, right, by multiplying by 1/2 times 1/2. And the same as down here. It's like times 1/2. That's kind of weird saying, yeah, whatever. X means times here. Yeah, bad notation. Times 1/2 means compressing by 2. So first, x coordinate is 1/2. Well, this point then becomes -1, 0. The y stays the same, right? Just the x is multiplied by 1/2. It makes it -1. 1/2 of -1 is -1/2. 0. The half of 0 stays the same. Half of 2 is 1, and again the y stays the same. Only the x. Half of 3 is 1.5 comma 0. Okay, that's our first step. Now we shift it to the right 1/2 in the x. We add 1/2 to the x. Negative 1 plus 1/2 is negative 1/2 comma 0. Just adding 1/2 to the x, our step 3 here. Negative 1/2, that becomes 0. Negative 1/2 plus 1/2 is 0 comma 0. Again, y is the same. This would be 1/2 comma 0. This would be 1.5. Sometimes I'm doing 1/2, sometimes 0.5. I don't know. Oops, comma 3. Either way works if you like decimals. 3. 1.5 plus 1/2 is 2 comma 0. Okay, now we're taking last step, the y, and cutting it in half, multiplying by 1/2 or compressing it by 2, right? Twice as small. So this point becomes, again, the x's stay the same now. The y, 0 stays 0, right? Multiplying it by 1/2 stays 0. This point stays the same because it's 0 comma 0. So it stays the same. Again, multiplying the y by 0. This one also stays the same. 1/2 comma 0 because the y stays 0. Let's see. And I think I messed up way back here. I did. This was a 1. You guys aren't here to catch me on these things. You're not supposed to change the y. We're not changing the y here. Not changing the y here. This was a 1. I knew something was messed up. So here, sorry about that. Here our 1, we're halving it, so this becomes a 1/2. Yes, that looks right. Okay. 1/2 of the y again is 1.5. Half of 3 is 1.5. 1/2 of the y again, 0 stays 0. So those are our new points. Now we can plot those points. So finally we're going to graph this, and we're going to plot all those points and then connect them to make them look like the picture we had before. So you could do it on the original picture, but you can only do that so many times, and you know, how does that work exactly? Just do a new picture. So we're going to need to go from like x from negative 1/2 to about 2. So I'll say 1 is like right here. So this is 1, negative 1. So this would be positive 1, obviously. This is negative 1, 1, 2. Okay, now let's plot the points. Negative 1/2 comma 0, that's right here. 0, x equals 0, 1/2, that's right here. 1/2 comma 0, that's right here. 1/2 comma 1.5, 1.5. Okay, here's 2, so that would be 1.5 is here, that would be right there. And then 2 comma 0, 2x is 2y, oh, that would be right there. So our new thing would look like this. It goes up, comes down, goes up again, comes down like this. And again, I'm not worrying about these endpoints. You could do those too, but I'm not going to worry about it. You don't need to worry about those for this problem. If there's on a final or something, yes, worry about those, but it's just the idea, because those also get shifted and we know where they started. But keep it simple, just do the major idea what the graph would look like. So that's what it looks like. The answers are in the back of the book for these. Unfortunately, not all the answers are in the book for chapter 13, as you'll notice. So I'll try to give out those answers and do some more examples of those. But that's the basic idea. It's the easiest way to do it is to take the points and have the order of operations here, figure out what you do, and then shift all the points, and then finally draw the graph. You can do it. You can take the graph and like, okay, shift it 1/2, make it here, and draw a new one, and then do that one, do that one. It gets to be a mess really fast. So I recommend you do it this way. Now, this one, if we could have made it harder, let's say that our function had a +5 here. Okay, let's say we added 5 to it, like the last one has a -2. That just means at the very end, we would shift it upwards. Again, in the y direction, it's always the same, upwards 5. So we'd have added 5, the very end, last step, we'd have added 5 to all our y coordinates, which means we just take this whole thing, and move it up 5. If we had had a negative x, then we would have reflected it around the x-axis. which means we just take our x and make a negative. So if the x was negative here, or if the y was negative, this was negative 1/2, we'd have just changed our y's, every y, change it from negative to positive, and of course 0 stays 0. So doing the points is real easy, makes it real easy to do this. You just do whatever you do to the y or the x coordinate or the y coordinate, and then you plot them at the end. Anyway, hopefully that makes sense. Let me know if you have any questions. And yep, bye.